Virtualization is the process of creating a software-based or virtual representation of something rather than a physical one. This can apply to applications, servers, storage, and networks, and is the single most effective way to reduce IT expenses while boosting efficiency and agility for all size businesses. It allows you to run multiple operating systems on a single physical machine, sharing the resources of that single computer across multiple environments. Different virtual machines can run different operating systems and multiple applications on the same physical computer. It's like having multiple computers operating on one physical hardware. While virtualization exists, there are several approaches that are used, and they include full virtualization or virtual machine model. This approach allows multiple virtual machines, VMs, to run on a host machine, each with its dedicated operating system, kernel, and virtual hardware. This ensures complete isolation between VMs, making it suitable for applications with different requirements and strict security obligations. Virtualization at the OS level. This approach allows multiple instances of an application to run in an isolated form of a single operating system. It's a lightweight form of virtualization that provides high levels of efficiency and performance. Hybrid virtualization is a virtualization technique that separates resources or services from a physical delivery system within a hybrid cloud. Hybrid environments consist of two or more interconnected virtual containers, private cloud or public cloud environments. With hybrid virtualization, you can create several virtual systems by leveraging the pre-existing physical component of a hybrid server. Hardware-assisted virtualization is a platform virtualization approach that enables efficient full virtualization using help from hardware capabilities, primarily from the host processors. It is used to emulate a complete hardware environment or virtual machine in which an unmodified guest operating system using the same instruction set as the host machine effectively executes in complete isolation. With the component all listed, let's now take a look at the types of virtualizations that exist. Firstly, we have the operating system-based virtualization. Is a feature where the kernel allows for isolated user space instances by installing virtualization software over a pre-existing host operating system. This allows users to operate and generate virtual machines, but may affect hardware compatibility issues. It also allows running programs within containers where only part of the allocated resources is visible. Network virtualization is the integration of hardware and software network resources into a single software-based network. It can be external or internal and is used in software testing to simulate network environments. It's a crucial component of application performance engineering, allowing developers to simulate connections between applications, services, dependencies, and end users without physically testing the software on all possible hardware or operating systems. Server virtualization is the process of dividing a physical server into multiple unique and isolated virtual servers by means of a software application. Each virtual server can run its own operating systems independently. Full virtualization uses a hypervisor to monitor resources and keep virtual servers independent. It can slow down applications and impact server performance. Para-virtualization combines the entire network as a cohesive unit, reducing the need for a hypervisor. OS-level virtualization performs all tasks of a hypervisor, but requires all virtual servers to run the same operating system. Desktop virtualization is a technology that allows users to access a desktop from a connected device, separating the desktop environment and its applications from the physical client device. It is a key element of digital workspaces and depends on application virtualization. Two main types of Desktop virtualization are local and remote. Local. Virtualization runs on a client device, allowing processing and workloads to occur on local hardware. Remote. Virtualization operates in a server computing environment, providing IT centralized control and maximizing hardware. Investment. In virtualization, the essentials component to be known are the physical machine, which is the physical machine that provide computing resources to support virtual machines. The hypervisor, which is an application or firmware that enables multiple guest operating system to share a host's hardware. Resources. Management console, it is used to access, configure, and manage the virtualization product. The management server, it is a virtualization platform component used to directly manage the virtual machines. And the virtual machine, which is an independent instance of an operating system created by Virtual Machine Monitor. When most people think of operating system, OS virtualization, they think of the cloud, VMware and server virtualization, which was built primarily for efficiency. People don't think about endpoints or security, mostly because they aren't familiar with it in the context of end-user devices. But OS virtualization, when applied to endpoints, is designed specifically for security. Operating system virtualization eliminates the endpoint security problems inherent in virtual desktop infrastructure, VDI, browser, and application virtualization software. It protects sensitive information against all attack vectors and, in contrast to those other approaches, ensures the performance that knowledge workers need and expect. With OS virtualization, end users can access, install, and work with websites, apps, external devices like USBs, and cloud services as they need, without security constraints and without worrying about endangering or compromising their company's sensitive data. How operating system virtualization works. The process involves a combination of software and hardware elements working together in a specific way. Let's dive into the process. The hypervisor is a key component in OS virtualization. The hypervisor is a software layer placed between hardware and operating systems of virtual machines. Its role is to manage and partition the system's resources so that each VM gets what it needs to function. Creating virtual machines. Once the hypervisor is installed and configured, we can start creating virtual machines. Each VM functions as a self-contained system with its own operating system and applications. Resource allocation. It ensures all configured VM gets its share of hardware resources like CPU, memory, storage, etc. It does this by partitioning the physical resources and assigning them to each VM per its requirements. Managing VMs. The hypervisor continuously monitors the VMs to ensure they are functioning correctly. It manages the startup and shutdown of VMs, monitors their resource usage, and reallocates resources when necessary. Interacting with VMs. Users can interact with VMs just like they having a physical computer. They can run applications, change system settings, and even reboot the system if necessary. Isolation. The hypervisor ensures isolation among the VMs, meaning that each VM is unaware of the others. This is crucial for security and stability. If one VM crashes or gets infected by a virus, the others remain unaffected. To understand why OS virtualization is so effective, let's take a quick look at how it works on the endpoint. How endpoint OS virtualization works. OS virtualization technology runs below the endpoint device's operating system, just as it does in the data center. It splits each device into multiple local virtual machines, each with its own operating system. Everything end users do happens in different operating systems, which run side by side with full separation. The virtual environments are isolated using the hypervisor technology. In addition, none of the virtual environments can access the corporate network directly. Instead, they each connect through an invisible network virtualization layer that applies network segmentation on the endpoint. In most OS virtualization implementations, the hypervisor manages 2 to 3 virtual machines running on the device, one per user persona, security zone. A typical set of virtual machines that run side by side includes fully locked down VM for accessing sensitive corporate data and systems, e.g., IT systems, payment transaction systems, sensitive customer data, unlocked open VM for unrestricted access to non-corporate resources, e.g., browsing the full web, installing any application, using external devices, semi-locked down corporate VM for accessing standard corporate applications, e.g., Office documents, corporate email, internal services. Each VM's access is limited according to the security zone it belongs to. The open VM can only access the wild internet. The corporate VM can only access non-privileged corporate network. The privileged VM can only access privileged resources. Full OS virtualization solutions, like the Hypervisor platform, ensure that users always use the correct virtual OS. If they try to perform tasks in the wrong VM, they will be automatically redirected to the correct one. Hypervisor ensures hackers cannot move laterally in the network to access privileged information. Malware on internet-exposed virtual environments cannot reach or see sensitive resources, which are only accessible via the privileged VM. In fact, hackers can't even see that other VMs exist. Malware can only access the open VM that it's contained within, and for added security, that open VM can be programmed to be non-persistent so that it's automatically wiped clean at prescribed intervals. It can also be remotely wiped clean when required via the Hypervisor management console.